Mike. All right. Can everybody hear me fine?
Oh, yes, we can hear you, Rohan.
All right, guys. So let's wait a couple of more minutes for some more people to join in, and then we'll start with today's webinar. So, Prabal, shall we start? All right. So I'm turning on the camera now. Hope everybody can hear me and see me fine. Okay. Push my screen, share, desktop two. All right. So can everybody see my screen? All right. Cool. So welcome, guys, to webinar number 3, our third session of the webinar for our virtual hackathon. Welcome. Today, what we're going to do is we're going to kind of build on top of what you have learned in the previous 2 webinars, right? In the previous 2 webinars, you kind of got like an introduction into like blockchain, into Web3, and then an introduction into what our Culp Studio platform is doing as a whole, right? And kind of how to use it. So in this session, what we're going to do is we're actually going to build like a whole dApp from basically scratch, right? Using Culp Studio. So what we'll have today is number one, we'll have a couple of smart contracts. We'll have a front end in which we will integrate what we learned in the previous sessions, right? And we're going to be using the API gateway today. So I can't turn this off. Okay, cool. Okay, so Divya is asking how to find teammates for this hackathon, or is it mandatory to participate solo? Prabal, can you help me with that? Okay. So I believe it's not mandatory to participate solo, but you can if you want to. At least that's how our previous hackathons have been working, and I believe it's the same for this one. So let's kind of move forward to the actual demo for this, right? So I'm going to be sharing the GitHub repo for our session today, right? So let me just copy this. Mac. Right. So I've pasted the GitHub link on chat if you guys want to like kind of follow along and see what's happening, right? And if you open up the GitHub, what you'll see is that it has three parts. It has a balance manager, which is our front-end dApp. It has a simple token folder. This is our smart contract for Culp blockchain, right? So it's in essence, what we have is that we have our own proprietary blockchain, but we also can connect to normal EVM-based blockchains like Polygon, Ethereum, etc. I believe we are now supporting like a couple of different blockchains now. And we also have simple token.sol, right, which is a basic Solidity smart contract, which is the same as the smart contract here, which is written in Go, right? So let's start off by looking at something which is a bit more familiar, right? So which is the Solidity smart contract. So this is a very simple token, right? It has three basic functions. It has an add balance, it has a remove balance, and it has a show balance, right? And for add balance, it has the following parameters, which is amount and account. So you can add balance to a particular account, a particular amount into a particular account, right? Similarly, with a remove balance, you can remove a certain amount of balance from a particular account, right? And show balance just shows the balance of a particular account, right? A very simple smart contract. And yes, everybody can participate, Divya. It's not only limited to students. People who are working can also participate. So, and the way it's storing all of this data is through a mapping, right? This mapping called balances basically stores the balance of each individual address, right? So it's a mapping from an address to a UN256 in which the balances are being stored. And show balance just gets the balance for a particular account, right? It's pretty easy to kind of figure out, not much going on here, right? And as I said, I've pasted the GitHub link on the chat. So, so if you guys want to kind of look at it, yeah, you guys can clone it, run it for yourself, be my guest, right? Now let's kind of move forward to the Culp side of things, right? So I've also created a simple token smart contract for Culp. And for our Culp Tantra blockchain, we basically use Golang to write our smart contracts, right? So if we kind of go into main.go, this is where you'll find all of the functionality of the smart contract. And it has the same three functionalities, right? It has an add balance, it has a remove balance, and it has a get balance. So instead of show balance, it just has get balance, right? And the way it is actually storing all of this data, right? The balances is through a balance prefix, right? And in Culp smart contracts, what you do is you essentially create like a composite key. You actually store values as a key value pair, right? So the whole, what do you call it? The whole documentation for this, if you want to learn how to create smart contracts in Go, can be found on our website as well, on Culp Studio. I believe it's docs.culp.studio, right? And you can kind of go through that and understand how to write smart contracts. But here we just have that same simple smart contract with that add balance, right? With the parameters of account and amount, right? This first parameter is just to make sure that all of these key value pairs are being created, right? You get state, you put state, etc., using this context parameter. This is not shown on the API gateway, right? Because the main parameters are the parameters after CTX, which is account and amount. So it's doing almost the same thing. If we go back to the Solidity smart contract, it's for add balance, it's checking to see if the amount is actually greater than 0 before adding that balance, right? So similarly over here, it's checking to see if it is less than or equal to 0, then it's just saying that must be positive. Same difference, right? Then what it is doing, it is actually creating like a composite key, because as I said in Culp smart contracts, the data that you actually store on the blockchain or the state of the smart contract itself is actually stored within key value pairs, right? So before actually storing any value, you have to actually create a composite key. This key will store the value that you want to store, right? So after creating the composite key, what we do is we retrieve our current balance and add our new balance to that current balance, right? So once we retrieve that current balance by using ctx.getState and the balance key, we'll get the balance bytes. We convert that into like an, I believe it is a uint 64, right? Which is here. If balance bytes is not nil, it's just checking to see if it's not nil, then parse uint. So it's just converting that into this balance bytes into a uint. And then it's adding the amount on top of the current balance to get the new balance. And it is then putting that new value into the same balance key that we created above here, right? So pretty simple stuff. Similarly, with remove balance, it's just checking the opposite, right? It's first checking that the amount must be positive, and it's also checking to see whether you have enough balance or not over here, right? So if you try to remove like an amount of balance, which is an amount which is greater than your balance, right? It will throw you an error because that's not possible because we are storing these values as uints, so uints can't be negative, right? Unsigned nits. Similarly over here, checking to see current balance must be less than amount, right? Insufficient balance. And then it's subtracting that balance and storing that balance into the balance key to update that balance on the blockchain itself. Yeah. So the actual, as Prabal has said, the actual dates for this hackathon are starting from tomorrow, from the 26th to the 30th. So best of luck, guys. And I'll just go over get balance as well. It's again very simple. You're just using the ctx.getState to first you're creating the composite key, and then you're getting the actual value, converting it into a uint, and sending it back, right? And this main function, what it does is that it basically just uses our Culp SDK to create a new chain code, right? So that it's actually deployed on our Culp Tantra blockchain. That's all you need to understand from here, honestly, right? So from what we've learned up till now is that we have our smart contract, which has these three functions, right? So let's go ahead and see how it looks once it is deployed, right, on Culp Studio. So let me go through the entire deployment procedure, I guess, right? So in order to deploy, I need to connect my wallet first. For this demo, we'll be using the Polygon Amoy testnet, right? So connect wallet, Culp Studio. I'm using a custodial wallet for this. The API gateway currently works only with custodial wallets, mind you. So you need to use like a custodial wallet for this. So I'm going to select my Polygon custodial wallet. My balance will be updated here. This is how much test Pol I have. And let's deploy a new smart contract. Let's say this is simple token 3, right? And for the category, I'm going to choose tokens. Yeah, there it is, tokens, right? The description is honestly optional, so I'm going to leave it blank. And once we come over to this screen, what we'll do is that we'll open up our handy dandy file explorer or Finder in Mac, right? And I already have this open. So I'm going to just drag and drop this simpletoken.sol file and hit continue. And what this does is that it automatically deploys your smart contract. It checks to see if it compiles, then it deploys it using your custodial balance over here, right? And once that's done, honestly, deployment super simple, right? You see that you have simple token 3. Now for the API gateway. Now how the API gateway kind of works is that what it does is that it creates these automated routes for you, right? So you want to kind of interact with your smart contract, right? It's already deployed on a particular testnet. You will get your contract address as well. But to make things a little bit more simple, what we do is that we'll give you a smart contract address. You can interact with it normally as well. But we also give you these functions, right? And you see that these functions are the same functions which we have on our smart contract itself, right? So let me just go here. I deployed simple token.sol, right? So it had 3 functions: add balance, remove balance, and show balance. So you can see that it has the same 3 functions. And if I was to explain how it does this, is that it actually uses the ABI, which was actually created when actually compiling down that smart contract. And it uses that to kind of extract all of these different functions that can be called on the smart contract itself. And if you see that the routes are given for each of these functions, right? So if you copy this, let's go to show balance. Let me just create a new tab and I paste this over here. You will kind of see that it has a couple of different things in it, right? And let me not paste it here. Let me just paste it over here, right? Right. So what you'll see is that, first of all, this is an EVM smart contract, and you'll see that your contract address will be shown over here, along with your function name, right, for show balance. So you can kind of see how this is structured, and we'll kind of see it a bit better once we look at the actual front end, which is actually working for this, right, for the little dApp that I created. So let's go back to Cult Studio. So it'll give you the route. It'll also give you a bunch of parameters, right, that you have to add to that particular request. So this is the body of the request that you have to send to this particular route. And if we can see, this is for add balance, I believe. It has amount and account, right? And if we go back to simple token, it has the same parameters, account and amount and account, right? So this is where you'll send your arguments for your particular smart contract. And you can also choose which wallet address you want to use. If you have like multiple custodial wallets, here you can actually swap between them if you want to change the message of sender for this, right? And it also shows this is just identifiers to where this transaction actually heading to, which blockchain it is heading to, right? Along with, you'll have a bunch on the API key tab. You'll have your API keys, right? And these are important for actually calling the particular smart contract function, right? So let's actually kind of go into the actual demo, right? Let me just show you what like a functioning DApp will look like for this. So npm and start, uh, sorry, cd balance, and then that. There we go. All right. So this is our balance manager DApp, right? So if we kind of look, we have like an enter account, we can get the balance, right? Which is very synonymous with our show balance, right? It requires an account. So let's kind of get an account somewhere, right? Um, let me try to use this wallet here, right? Can we copy the address here? Mm, mm, it does. This is so strange. Anyways, let me just get the wallet address from here itself. I'm just going to use this wallet address for the time being, right? And we go back to our tab. We paste our wallet address here, and we click on Get Balance. It takes a little bit of time, but it shows that our current balance for this particular account is actually 0, right? Let's try to add a bit of balance to this, right? So let's add like 100 tokens to this. And this is like pretty arbitrary, the number of decimals, right? Usually ERC20 tokens have a particular decimal, uh, uh, particular set of decimal zeros, right? So this is pretty arbitrary in itself. So, okay. So it took a little bit of time, but it did add the balance successfully, right? And now if we click on get balance again, we should see that the current balance was updated to like 100, right? And similarly with this, we can like subtract 50, or let's say 35 from here, remove balance. It takes a little bit of time because of course it's sending like a transaction to the actual blockchain, to the testnet, and it kind of varies from blockchain to blockchain. It's usually 15 seconds, right? So in the meantime, you can add like a loader or something. I haven't because this was like a pretty small demo. And it did say balance removed successfully, right? And then now if we click on get balance on this, we can see that the balance was updated to 65. Now, how exactly does one go from having all of these different routes on Gulp Studio to like a functioning DApp over here, right? Let's kind of dive into like the code of this. So if you guys open the balance manager for this and head down to src and app.js, sorry, you'll see that it's literally like a one-page app. So most of the code is over here. The rest is all CSS and logos and whatnot, right? It's just a React app. So we have a bunch of different states, right, which we are using to kind of keep track of all of these different inputs, right, and the balance, right? So that's what these are. What I've done here is that I've added like an API URL, because the way that the API gateway is kind of set up is that we have like our domain over here, /contract/EVM. If you're using like our Culp blockchain, then it would be /culp, right? Followed by our contract address. I've saved that separately. And I've also added my API key over here, right? And this API key is the same API key which you get when you go to check params and API auth key. And I'm using the webinar 3 one, right? Similarly, another place you can see your API keys are over here. You can see all the different API keys, right? Let's get back to this. Actually, I'm using Simpleton too, right? So I just pasted my API key over here. which you shouldn't, honestly, you shouldn't do, but I'm going to disable this after this demo anyways, right? After this webinar anyways, so that's fine. Honestly, you should have your API key in your environment variables, right? On your .envs. So, and you can also have your contract address over there as well and whatnot, right? No worries about that. But for like webinar purposes, I've just put them over here. So let's kind of see what happens when we actually click on the Get Balance button, right? If we kind of scroll down, you'll see a bunch of HTML. You'll see that this is the Get Balance section. H2 Get Balance represents this text over here. And this input box is this input box, right? And it has a button which goes to Get Balance. And what this Get Balance function, what it does is that it actually calls the API route, which was generated by Cloud Studio over here, right? So I'll just do one thing. I'll just enter and paste this over here, right? It's actually calling this particular route, and this is going to be an axios.post request, right? So we have our API URL, which is this part, right? Followed by query, which is whether it's a query or an invoke. Query basically means that you're getting getting data from the blockchain, and invoke is basically you're putting data into the blockchain, right? You're changing the state with invoke, and you're just getting data from query, right? Followed by your contract address, which is over here, and then your function name, right? And okay, and then it's sending like the request body, which is over here. So for this, it is here. So you'll just have to copy this, paste this over here, and then change the account on this. You can also put your wallet address in your environment variables, right? And whatnot. So, but I've just pasted it over here, right? And this account is just getting the state, um, the get state from use state on React, right? For the get balance account. And under headers, now this is where your API key kind of comes in, right? So under your headers, you'll have your content type and then your X-API key, right? And this is where you'll paste your API key. So without this, you'll not be like authorized to use the API gateway, right? And also, yeah, as Prabal said, you can also view the same thing on our YouTube channel if you want like more in-depth kind of tutorial on how to use this, our API gateway and our Cup Instant deployer, right? So it's just doing a axios.post request over here, right? It's saving it under response. And then what I'm doing is I'm console logging. This was just to see what I'm getting from the actual response for this, right? So if we kind of go here, inspect elements, right? Go into network, get balance. You'll see that this is the actual this is the actual response that you get for like a successful query of show balance, right? So the result is basically just a big number, right? The hex is given, so you can convert that into like an integer, right? And this is what this line is particularly doing, right? So it is setting the balance. It is using ethers.getBigInt. It's using the hex value from here, which is this hex value, which is 0x41. And it is converting it into a string and then setting that and then showing that particular balance on our dApp on our page, right? Some try-catch stuff going on here. If there's any error, it'll show error fetching balance and whatnot, right? So all of these particular users of the API gateway, I would say, are going to be axios.post requests, right? And we'll see that when we kind of go into like the add balance part of it. So what this is doing is, instead of it being like a blockchain query, it's going to be a blockchain invoke. And invoke is just our fancy way of saying that it's actually changing the state of the blockchain. It's adding data into the blockchain. That's basically what that represents, right? And this is an add balance, right? Same stuff here, Amoy Polygon, wallet address, and then your args over here, right? And if you kind of go into Culp Studio, into the check params for add balance over here, you'll see that you have an amount and an account, right? Same difference from the smart contract itself. It's just the parameters of the smart contract, right? So, and API key, once this request is sent, you'll get a response, right? But you don't honestly need to show that response. You just need to show that it's successful, right? I'll show you like what you'll get for a successful invoke, right? So let me just go back here and let me just click on add balance, right? So you'll see that add balance is actually working right here, right? Just give it a few seconds. It'll come up with a response for this as well. There we go. So this is the kind of the response that we get for an invoke of an EVM blockchain, right? So under result, you'll see that the to will be your smart contract address. The from will be your wallet address, right? Contract address is null. I don't know why, but that's just what we get. This is the amount of gas used. So if you want to kind of track that, you can also do that. Logs, Bloom, block hash. You can get the block hash for this as well. You can get the transaction hash. All of this good stuff you do get, but I'm not using any of that. So that's up to you if you guys want to use that as well, right? Lots of good stuff here. So you also get the events which are kind of being emitted for this, right? Good stuff. And once we add balance, right, we get balance again. Because I added another 100, it should change to 165 over here, right? Same stuff. And what I'm doing after I'm like successfully doing this axios.post, or rather this post request, is that I'm just setting a message for balance that I did successfully, and then setting the balance, right? Or rather resetting the balance to null to kind of reset, so that you have to click the get balance button again to kind of show the refreshed balance, right? Similarly with remove balance, it's literally the same thing as add balance. The only difference is that under the URL, it's just remove balance, right? So this is like a very simple dApp that you guys can kind of clone. Yeah, feel free, as I said, I'm gonna paste the link for this GitHub repository again in chat, right? Feel free to clone it, play around with it, kind of just use your own API keys, use your own smart contracts and whatnot, kind of study it. Feel free to do whatever with it, right? So yeah, that's that. That's the essence of webinar 3. So do you guys have any questions for this? So Hemant is asking, for hackathon, is it necessary to deploy smart contracts using Culp testnet, or can I use other testnet as well? Like, what are the requirements to be eligible for prizes? I don't believe it is a requirement to use our Culp testnet, right? You can if you want to, it's there. But you can honestly just use any other testnet for this, right? It's all up to you. If you guys want to learn about Golang, about smart contracts in Golang, feel free. We will be more than happy to have you use our Culp testnet, right? But if you guys want to use like Ethereum or Polygon, go ahead. It's your choice, right? And I believe, let's see. let's try to create a new wallet, right? So we'll need to create a custodial wallet. Again, I'm reiterating this, right? This API gateway works only with custodial wallets. So make sure you have a custodial wallet for that, right? So we have Ethereum and Polygon currently, right? And then you can either use Amoy or you can also go on mainnet if you want to. For Ethereum, you have Holsky and Sepolia, right? You can use any testnet that you want. Is there any API package from Cloud Studio to fetch real-time market insights? Not yet. There are no packages for that, although there are going to be additions to Cloud Studio coming very soon for that. Divya is asking, hi, do we need to complete full dApp end-to-end in 4 days? And that's essentially how hackathons work, right? You have to create like a whole dApp, have it working within the given constrained time period, right? Do your best. Do your best and hope for the best, right? Are there any more questions? What can non-it do in hackathon? Could you, Anmol, can you rephrase that question? I'm not able to understand it. Are you asking what can't you do in a hackathon? Oh, or non-IT. Okay. How can you contribute? Honestly, a non-IT person, if you want to get into like development and whatnot, hackathons are mostly just projects, right? People build projects within a certain time period and then showcase what they've built, and the best person wins, right? So kind of just get into the coding, I would say, right? It's not really that hard to use. Cloud Studio actually makes smart contract deployment and all of that. It just handles all of that for you, right? All you have to learn is like a little bit of Solidity. And honestly, if you've done like even a little bit of coding before, Solidity is not that hard to learn. Golang, on the other hand, is a little bit harder, right? But um, and honestly, I'm kind of excited to see like what the projects are going to be for this time, right? For this virtual hackathon. So Solidity we use for EVM-based smart contracts, right? And if you want to use our Culp blockchain, you'll have to use Golang for that.
Hello.
And for
Hello.
your
Am I
use whatever, right? You can use React, you can use Vue, you can use Python if
audible?
you want. Yes, you are. For building your front end, sure. Why not? You can use Java for all I care. I don't think it's like a for like front end, back end stuff, it's not really limited to anything, right? Whatever framework suits you. Honestly, for backend, if you want to use fast API on Python, you can. Are there any more questions? Oh, yeah, feel free to use whatever, right? From what I feel about like AI, is that it kind of helps you, right? Kind of learn um, how to code faster, and it does all the small stuff for you, right? It's very good for like a base. And again, building smart contracts, you can use ChatGPT and Gemini, but that only provides like a base for you. So are there any more questions? It's honestly, it's a great place to start coding, right? You have something, then you can build on top of it. if that's all, then thank you guys for attending our webinar 3. Best of luck in the coming days, and yeah, see you guys. Hope you guys have fun, right? Right. Bye-bye.
Thank you, everyone. Happy hacking.